Second order reaction, what is the formula? Second rate constant of the second order reaction means here rate constant of second order reaction. Rate constant of second order reaction. Second order reaction. So what is the formula we can write for the second order reaction means here? So K is equal to 1 by T into 1 by T into 1 by A minus X. That means final concentration minus of by initial concentration of the reactant. Okay, so one is we can write as here final concentration minus so one of the reactant here. This is the one formula we are using to calculate the rate constant of the second order reaction, but it is not there in our syllabus. Okay, simply for the just additional information I am giving here. Okay, and we already wrote the units also. What are the units of the second order reaction? Units of the second order.
Mole inverse, liter, second inverse.
Very good, ma. So mole inverse, liter, second inverse. Sir, how we are going to write the units of the second order reaction, third order reaction is we have a general formula. So what is the general formula we are having? What is the general formula we are having here? So m mole to the power of 1 minus n, okay, and liter to the power of n minus 1 and second inverse. So by using that formula, we are going to find out the units of the here second order or third order, nth order of the reaction. Okay. Now, so for the rate constant of the third order reaction, third order reaction. Okay. So what is the formula we are writing for the third order reaction means K is equal to, so 1 by 2T. So 1 by 2T into 1 by R minus R square. 1 by R square minus R naught. Okay, R naught square here. So 1 by R square minus 1 by R naught square. I think so in this one already we know here. So what is meant by the R naught here? R naught is nothing but initial concentration. R is nothing but here final concentration. T is nothing but time. So these are the general formulas we are having here. And what are the units of the third order reaction? Units. What are the units of the rate constant of the third order reaction? So what are
mole square inverse, liter square, second inverse.
Mole
Square inverse.
Square inverse.
Liter square.
Liter square. Second inverse. So these are the units of your third order reaction. Okay. So now you got the clarity. Okay. So and another formula, half-life period. So general formula of the half-life period. General formula of half-life period. Half-life period. Okay, so what is the general formula of the half-life period means here? T of is equal to 1 by a to the power of n minus 1. So 1 by a to the power of n minus 1. Okay, so based on this one, in this one r to the power of n minus 1 we can write directly. So to make you clarity here, so r, what is meant by the a is nothing but so molar concentration of the reactant. This we can write as r to the power of n minus 1. In some books, how they wrote as means here 1 by a to the power of n minus 1 also we can write. In this one, a is nothing but molar concentration of the reactant. A is nothing but here concentration of the reactant. Concentration of reactant. So by using this formula also, sometimes they're asking the question, what is the general formula of the half-life period? So what is the general formula of the half-life period? The half-life period means here T of is equal to 1 by R to the power of n. So all these are the some additional information. So which is required for the JEE mains level and advanced level. Okay. Now you got the clarity. Right. Now, so about concentration we discussed. So what are the factors affecting the Rate of reaction means here, so concentration here, one it is there. After that, temperature is there, surface area is there, okay, and catalyst also it is going to be affect the rate of reaction. What are the factors affecting the rate of reaction means? First point is concentration, second point is temperature, third point is surface area, fourth point is catalyst, okay, and pressure also we can take. Pressure also we discuss under the concentration only. Pressure also we discuss about the concentration only. Sir, where we discuss means here we derive for some formula. Okay. So whenever you take as a liquids means we are taking as a molar concentration of the liquids here. But whenever you take as a gases means we are taking as a pressure only. Na? So if the pressure is going to be increases means rate of reaction also is going to be increases. Now in that one second factor we can check it out here. So what is the second factor it is there means here temperature. Okay. So what is the second factor means here? So temperature. Okay. So what is the second factor means here? Second factor is nothing but here temperature. Okay. If the temperature is going to be increases, rate of reaction also is going to be increases. If the temperature is going to be increases means here rate of reaction also is going to be increases. Sir, how we knows, how we can confirm means here? Sir, Arrhenius scientist, he has given the relationship in between rate constant and temperature also. Okay, so which scientist has given the exact relationship between the temperature and rate constant and reaction means here Arrhenius scientist. Arrhenius. So Arrhenius, he has given the relationship between Arrhenius is given the relationship between the relationship in between rate constant and temperature and temperature. Okay, temperature. Clear? So now, according to that, how we can write the mathematical expression of the Arrhenius equation means here. So K is equal to A to the power of A into E to the power of minus EA by RT. Okay, K is equal to A into E to the power of minus EA by RT. Okay, so first, can you derive the terms? What are the terms are present in the Arrhenius equation means here? K is nothing but rate constant. K is nothing but here rate constant. Okay, and A is nothing but frequency factor. Which frequency factor means Arrhenius frequency factor. Okay, so A is nothing but Arrhenius frequency factor, and A also we can call Arrhenius frequency factor. Arrhenius factor. Okay, or Arrhenius frequency factor also we can write as here. Frequency factor also we can call frequency factor. And EA. So what is meant by the EA means EA is nothing but activation energy. A is nothing but here activation energy. Okay, and R is nothing but universal gas constant. Universal gas constant. Okay, gas constant. So what is the value of the universal gas constant value? Any one of you who are logging today? Khyati, Ritu, Sai, Ekshit. Samnita is absent. Aditi is absent. Okay, now. So Kathy, what is the R value? What is the R value? Everywhere we are getting as a R value. Universal gas constant value. What is the universal gas constant value? Ritu?
I'm not sure, sir.
Ma, 8.314, ma. 8.314. It is a constant value. They cannot be changed. 8.314. Okay, 8.314 joules it is there. Okay, if you take in calories means we can take as a 2 calories. 2 calories we can take as Got the point here? So what is the unit? What is the R value means here? In joules, we can take as a 8.314, and T is nothing but temperature. Okay, so we can write as T is nothing but here temperature. Temperature. Okay, so this is the equation. It represents as an Arrhenius equation. Okay, it gives the relationship between the temperature and rate constant. Okay, according to the Arrhenius equation, if the temperature is going to be increases, rate of reaction also is going to be increases. Point number one. First, temperature is going to be increases. Okay, temperature increases. Rate of reaction also is going to be increases. Rate of reaction also increases. Okay, at the same time, by increasing of the 10 degrees centigrade, by increasing of by increasing of 10 degrees centigrade of the temperature, 10 degrees centigrade of the temperature, rate constant is rate constant is doubled. Rate constant is doubled. Okay, so by increase the 10 degrees centigrade of the temperature, so rate constant it becomes as a double. Okay, so by increasing the 10 degrees centigrade of the temperature, rate constant is going to be increases how much time here? It is increased by double here. Okay, it is increased by double also. Clear? If you're having any doubt, my dear. Okay, and here, so this one we are going to be explain. So two things for here. So based on here graphical method also we are going to be explain. Another one is here comparison method also we are going to be explain. Okay, so what are the Arrhenius equation is that we are going to be represent with the graphically. At the same time we are going to be represent here comparison method. Okay, now in the first one we can take it for here. So what is the first one? It is that means here graphical method. We can take as a graphical method. First we can take as a graphical method. So before going to the graphical method, first we can write as a equation. So what is the equation we wrote as here? K is equal to A into EA to the power of E to the power of EA by RT. Okay. So both sides if you multiply with natural log. Okay. Both sides multiply with natural log. If you multiply with the natural log means how we can write? Natural log k is equal to this one log a into b. Log a into b means how we can write as here? How we can write ma? How we can simplify log a into b? Ritu. Ritu is giving answer. Ritu, what is the answer?
I was thinking of something, sir, but I'm not sure if that's the answer.
Ma. Log ab value. How we can write as a log ab? Kathy?
Log A.
What is the log ab value? Log a plus log b. Okay, so what is the value of log AB means here log A plus log B. So according to that one, how we can write as this one means here natural log of. So natural log of A plus natural log of A plus natural log of e to the power of minus EA by RT. So this one is a power m value this. So this one is here a power m. If a power m means that we can write as a m log e here. Okay, m log e. M log e means this directly in place of e we can write as a constant value we can take here. So directly we can write as a natural log k is equal to okay natural log a into so minus into plus here you will get as a minus EA by RT is the formula. Okay, so whenever you are converting to the natural log natural log into log base 10. So whenever we are going to convert the natural log into log base 10 means we have to multiply. Generally, we are multiplying with the 2.303. But in this one, so we'll get as a denominator part. Okay, so log K is equal to log A minus of EA by 2.303 RT. So this is the finally formula we are getting here. So what is the final formula after multiplying with the log value means here? So log K is equal to log A minus EA by 2.303 RT. Okay, so for this one we are going to draw the graph here. Okay, so we are taking the log K value on the y axis. Okay, so what we are taking means here we are taking the log K value on the y axis. Okay, and so log K value we are taking as a y axis, and 1 by T temperature. We are drawing the temperature. We are explaining the relationship between the temperature and rate constant. Okay. Now what I told that if the temperature is going to be increases, if the temperature is going to be increases means what happened? Rate constant is going to be increases by 2 times here. Okay. Now if you see in this one, so by seeing the formula here, temperature and rate constant are inversely proportional, it is, sir. If it is inversely proportional means if the temperature is going to be increases, then what about the rate constant? Rate constant is going to be decreases or increases? From the formula, from the Arrhenius equation, Ritu. So what is the relationship between the rate constant and temperature in Arrhenius constant?
The temperature increases, the rate constant also increases.
But that is a general concept here. But in this graphically, so from the equation, how we can represent this one? This inversely proportional or directly proportional? Here is log K, it is there.
Inversely proportional, sir.
Inversely proportional. Inversely proportional means if the temperature is going to be increases this side, so rate constant is going to be decreases. Decreases means you will get like this here. Okay.
Yeah,
Okay, so because of inversely proportional it is then, so that's why it is decreases in this manner. And what is the slope? So actually by seeing the formula it look like as a y is equal to, this part is called as a mx and this part is called as a c here. Okay, in this one x value what we had taken 1 by t value, and what is the y value we had taken? Y we had taken as a log k. Then according to that one, what is the slope? What is the slope? Slope is nothing but EA by 2.303 R only now. So minus of EA by 2.303 R. Okay. So what is the slope in the given reaction? Means slope is equal to minus EA by 2.303 R. Okay. Now you understood here from the formula. By using the formula, we are going to draw the graph. Okay, by using the graph, we are going to explain the relationship between the temperature and rate constant. Okay, how it look like means here, it look like as a decreasing cell. So this we can call as an intercept. What is the intercept means here? Intercept is nothing but log A. So what is the intercept means? Intercept you will get as here log A. Clear? So what is the intercept in the given equation means here? Intercept is log A. Intercept. Okay, intercept is here log A. What is the slope means? Minus EA by 2.303 R. Okay, so this is the one method. And one more formula also it is. So based on this formula, sir, where we are using this formula means to calculate the Arrhenius constant. If you want to calculate the Arrhenius constant, if you know activation energy, if you know the rate constant, if you know the temperature means here, this formula can be used to calculate the Arrhenius constant value. Okay. For this one, in this chapter, what is the main drawback means log values. Formulas and at all easily we can remember and we can apply also. Where we are getting the problem means in the calculation part. If you know the log values, then only it is easy, especially in this part also. Okay, and another equation is that. So what is another equation means? Comparison method one it is. So whenever you're going to compare the equation 1, equation 2, we are getting as a one more equation. Okay, another one is comparison method. Comparison method. By using the comparison method also, okay, we can explain the relationship between rate constant and temperature. Sir, how we are going to be explain means here, for example, first formula log k. So in this one k we are considering this as a rate constant. K1 is equal to log a minus ea by 2.303 R T1. That means T1 is a different temperature. So this is the first equation we are comparing here. That we are considering it as the first equation. And second equation we are taking. Second condition, second rate constant. Log K2 is equal to log A minus of EA by 2.303 RT2. So this is the second temperature. That means if they had given two different rate constants and two different temperatures, if two different temperatures and two different rate constant means how we can derive the equation. How we can derive the equation means equation 2 minus equation 1. Equation 2 minus equation 1. If you write the equation 2 minus equation 1, what you will get? I want to check it out. So log k minus log of k2 minus log k1 is equal to, what is the equation 2? It is the log of a minus ea by 2.303 RT2. So this is the log second equation relation. Minus of log 1 it is there. So another one is there, log a minus ea by 2.303 RT1. RT1. Now we can simplify here. So how we can simplify? Log A minus EA by 2.303 RT2. Here minus into plus. You will get as a minus only now. Minus of log A. And minus into minus you will get as a plus. Plus EA by 2.303 RT1. Okay. In this one, plus log A minus log A is going to be cancelled. And what are the remaining things are there? So plus EA by 2.303 RT1 minus EA by 2.303 RT1. Now I am writing as a systematic manner here. EA by 2.303 RT1 minus EA by 2.303 RT2. In this one, what is the common factor it is there? What is the common thing it is there in this one?
EA by R.
EA by 2.303 R na? What is the
Oh,
common it is?
yeah, sir.
EA
Yeah,
by
EA by
2.303 or it is the common it is there. If we take common means we can write as a 1 by T1 minus 1 by T2. So how we can write means here log K2 minus K1. Okay, log K2 minus K1 means here log A minus B. Log A minus B value, how we can write? Log A by B value.
log A by
Log A by B. So finally, how we can write the equation means log of K2 by K1 is equal to EA by 2.303 R into 1 by T1 minus 1 by T2. So based on this formula also we are having some of the calculations. Okay. So based on this one also we are having some of the calculation. So these formulas based on this one tomorrow we will solve some questions here. Okay. Now we'll complete the another concept. So what is the another concept means here? So generally rate of reactions can be explained based on the collision theory. Okay, how we can explain the rate of reaction and where we are applying the collision theory means especially for the gases. Now you are telling that. So what you are telling that? So if the temperature is going to be increases, rate of reaction is going to be increases. Okay, sir, how the temperature is going to be increases, rate of reaction is going to be increases. It's here. So based on number of collisions. Okay, so number of collisions. If the number of collisions are increases, the rate of reaction also is going to be increases. That we are going to be explained based on the collision theory. Okay, so now here one more here collision theory. Okay. Okay. So what is another concept here? Collision theory. Collision theory. Collision theory. Collision theory. Now, let us see. Sir, what is mean by the collision? Okay, what is mean by the collision? First of all, anyone of you? What is mean by the collision? Sai Akshit, Khyati, what is mean by the collision? Sir, where we got this concept means here. Do you studied about the states of matter chapter? Kinetic molecular theory of the gases, one concept it is there for us. What, Ritu? Do you studied or not? Kinetic molecular,
Yeah, sir.
kinetic molecular theory of the gases. There also we are going to study about the temperature. Okay. So collision theory is applicable for the gaseous molecules. For which molecules, ma? Gaseous molecules. So generally, a small tiny particles are called as a gaseous molecules. Okay. Here, the volume of the gaseous molecule is completely negligible while comparing with the volume of the container. Is it right? The volume of the gaseous molecule is negligible while comparing with the volume of the container. Gaseous molecules are, they move in all the directions. Gaseous molecules are, they move against to the gravitational force. Okay, gaseous molecules are, they move against to the gravitational force. And one more point also we studied. Gaseous molecules are, they move with high velocities. Okay, so gaseous molecules are, they move with high velocities. For example, so let us consider it as a two gaseous molecules. So when the two molecules are collision is nothing but, so one molecule is bombarded with another molecule. If the one molecule is bombarded with another molecule means immediately they'll change the direction. Immediately they'll change the direction and they can move in another direction. Whenever they collide with one another, they cannot lose the energy. They neither lose the energy, neither gain the energy here. Whatever the collisions are happening between the gaseous molecules, perfectly elastic. Perfectly elastic. Okay. Similarly, okay. So gaseous molecules are having high kinetic energy. The kinetic energy of the gaseous molecules are increases by increasing of the temperature. Okay, kinetic molecules of the gaseous molecules are increases by increasing of the absolute temperature. So that is also we wrote one formula. Ke is directly proportional to the temperature, absolute temperature. So what we wrote in the equation means here, Ke is directly proportional to the temperature. This one we wrote in kinetic molecular theory of the gases. Kinetic molecular theory of the gases is applicable for ideal gases. What is the ideal gases, which we can call as ideal gas? Sai Akshit, which we can call as ideal gases. Which we can call as ideal gas, ma.
So when it follows PV is equals to NRT.
Very good. Okay, so which follows the PV is equal to nRT. Okay, the gas which follows all gas laws at all conditions of the temperature and pressure is called as a ideal gas. The gas which obeys all gas laws is called as an ideal gas. Okay, so kinetic molecular theory of the gases is applicable for ideal gases. Okay, same concept only we are applying for the collision theory. Okay, sir, we are talking about the collisions, number of collisions. Okay, before going to the collision, first we have to know some concept. So we have to know what is meant by the threshold energy. What is meant by the threshold energy? threshold energy. What is meant by the threshold energy? So threshold energy is nothing but the minimum amount of energy. Minimum amount of energy is required. Energy is required. Okay. Minimum amount of energy is required to involve the gaseous molecule. To involve the gaseous molecule molecule in chemical reaction. So what is meant by the threshold energy means here the minimum amount of energy is required for the gaseous molecule to involve, okay, to involve in a chemical reaction is called as here threshold energy. Okay, minimum amount of energy is required for the gaseous molecules to involve in a chemical reaction. Amount of energy is required for a gaseous molecule to involve in a chemical reaction. To involve in a chemical reaction. To involve in chemical reaction. So this is the definition. So what is the threshold energy means? Threshold energy is nothing but the minimum amount of energy is required for the gaseous molecule to involve in a chemical reaction is called as a threshold energy. Okay. And sir, how we can calculate the threshold energy and how we are going to compare the threshold energy means here. So threshold energy is equal to potential energy of the reactant molecule plus activation energy. Sir, how we can define the threshold energy means here? Threshold energy is equal to potential energy plus activation energy. Potential energy plus activation energy. Okay, threshold energy, potential energy plus activation energy. So if you know the threshold energy and potential energy means from that one we can calculate the activation energy also now. Activation energy can be represented with E. Activation energy can be represented with the EA. Okay, activation energy can be represented with the EA. Clear? So based on this energy only, again we are telling that exothermic reaction and endothermic reaction. Kathy, what is meant by the exothermic reaction? What is mean by the
Sir, it gives out heat.
So the substance which releases the heat energy is called as a exothermic reaction. What is meant by the endothermic reaction?
It absorbs heat.
In a chemical reaction, heat is going to be absorbed means, okay, in a chemical reaction, heat is going to be absorbed means that kind of chemical reactions are we can call as a endothermic reaction. In a chemical reaction, if the heat energy is going to be releases means that we can call as a exothermic reaction. So exothermic reaction and endothermic reactions also we can explain graphically. So how we can explain the exothermic reaction and endothermic reactions means here. For example, so we are comparing the activation energy of the reactants and activation energy of the products. Okay. Now I'm taking as energy barrier on y-axis. Energy I'm taking on the y-axis and reaction coordinates. Reaction coordinates. Reaction coordinates. Okay, I'm taking on the x-axis. Now let us see reactant it is there. So this we are taking as a reactant. Okay, this I'm taking as a product. This I'm taking as a product. Okay, that I'm taking as a product. Now here somewhere we are taking as a minimum energy. Okay, so minimum energy we are taking. So let's consider it as a minimum energy. Now these are the reactants and these are the products. Okay. Now, if you compare the activation energy of the reactants, we compare the energy of the activation energy of the reactant, and we can compare the activation energy of the products. This side, whatever the energy it is, that from energy barrier to products, that we can consider as activation energy. Okay, so which one it is having the greater the value, whether products are having high activation energy or reactants are having high activation energy? From here to here, we can call it as activation energy. From here to here, whatever I wrote here, this graph is called as activation energy. So this one is the activation energy of the products. So which one is having the greater the value, either reactants or products? Kathy or Ritu?
So the products.
Products. Now in this condition, let's see when the activation energy of the products is greater than that of the reactant, then the given reaction is exothermic reaction. Then the given reaction is here exothermic reaction. Then the given reaction is exothermic reaction. So now you got the clarity. So when it becomes as a, when the given reaction is, we can say whether it is exothermic, endothermic, means here based on the activation energy of the reactants and products. Okay, the activation energy of the products is greater than that of the activation energy of the reactants is called as a exothermic reaction. With the same concept, if you write in a reverse manner, if you write in a reverse manner, here we are taking as energy and this one reaction coordinate, reaction coordinates, reaction coordinates. Now reactants I'm taking here and products I'm taking here. This one is represented as a products and this one it represents as a reactants. And I'm taking as energy barrier. So here I'm taking as a energy barrier. Okay, minimum amount of the energy. So minimum amount of energy is called as here. So threshold energy, right now? Threshold energy. Now from here to here and from here to here. Now, if you compare here, so this side is we are getting as a one activation energy, and this side we are getting as a one activation energy. Okay, so in this one, which one you having the greater the activation energy, either the reactants or products? Ritu or
The
Kathy?
reactant.
Reactant. If the reactants are having greater the activation energy, okay, so activation energy of the reactants is greater than that of the activation energy of the product. That time the given reaction is exhibited as a endothermic reaction. The given reaction is represented as a endothermic reaction. Now you got the clarity? Okay. So based on the activation energy also we can call here. What is meant by the activation energy? Sorry, what is meant by the threshold energy means here the minimum amount of the energy is required to involve in a chemical reaction is called as a threshold energy. Based on the threshold energy also we can explain the activation energy. Okay. So how we can define the activation energy means threshold energy minus potential energy is called as a activation energy. Okay, so threshold energy minus here activation, this one potential energy is called as a activation energy. Okay, now based on the reactants products, the activation energy also we can explain. And one more also it is the collision frequency we are calling. What is mean by the collision frequency? Collision frequency. First of all, what is mean by the frequency now? Collision frequency. What is meant by the collision frequency? Collision frequency is nothing but number of collisions takes place. Number of collisions takes place at unit volume. At unit volume is called as a collision frequency. Okay, so number of collisions takes place at unit volume is called as a collision frequency. Okay, so collisions also we have to take in a proper direction. Then only reactants are converted into the products. Okay, So then only reactants are converted into the products. If the collision does not takes place in a proper direction, that time reactants cannot be converted into the product. Now you got the point here. For that one also some example, diagrammatic example they had given. That is I can explain with a simple example. Sir, we are taking as 1 mole of the hydrogen gas and 1 mole of the iodine gas. So 1 mole of the hydrogen gas, iodine gas are bombarding, collision together means then only it forms as a 2 moles of the hydrogen iodide gas. Okay, this also we can explain in 2 methods. For example, this also one hydrogen atom, this also one hydrogen atom. Now, here also we have a one iodine molecule, and so here also one iodine atom. These two are collide together means then only it forms as a 2 moles of the hydrogen iodide. Otherwise, if you write in molecule like this one, here also one, this also one, and this also one, this also one. Let us consider it as a hydrogen. Let us consider it as a iodine. If collide together means only hydrogen, one iodine atom only colliding together. Na? Okay, in the second diagram, which one is having proper direction, which one is having improper direction? This kind of questions also it is there in JEE level, previous papers. Which of the following diagram is represent as a proper direction of the collision and which is improper or direction of the collision? First one or second one? First one?
Second one, sir.
Second one is improper or proper direction?
I guess it's improper.
It is improper here. Improper. So this one is proper direction. Okay, so proper direction means number of molecules product is going to be increases. Then only we can call it as effective collisions. Number of effective collisions are increases. Formation of the products also is going to be increases. Now we got it here. Okay, until here. So once you go through by tomorrow's class here, and last one concept it is that is nothing but catalyst. So that part also we can check it out in tomorrow, and we can solve some questions based on this one. Then I'll start the new chapter also. Okay, is that clear?
Yes, sir. Yes, sir.
So we'll continue in tomorrow class. So but before night only I'll text you. Okay, at what time you're having classes? Thank you all.
Thank you, sir.